Welcome everybody to our webinar tonight. It is all about cold climate heat pumps and more specifically about how you can replace your gas furnace at home with a cold climate heat pump. And what you're going to learn today from our presenter Dave is the advancements in heat pump technology, what kind of options there are for your home, some cost comparisons, looking at what might maybe a furnace AC looks at as opposed to just getting a heat pump that can cover both of those things. Some best practices, some pitfalls, kind of how to select some contractors. And we're going to take questions at the end. So a couple housekeeping items. There's a Q&A box. You can click on that button at the bottom of the screen to ask your questions, and we will get those answered for you. Dave did get some questions in advance that you asked when you registered, so he'll do his best to answer those as well. You can also raise your hand at the bottom of the screen if it's the end during the Q&A session, and we could probably allow you to talk if there needs to be some conversation. But we're going to just move forward and get going. I'm going to introduce you to Mary Weiner with Holy Cross Energy, and she's going to tell you all about our presenter. Take it away, Mary.
Thanks, Nikki. Welcome, everybody. I'm so glad you're spending a Tuesday night with us. It's a beautiful night here in Glenwood Springs, where I'm sitting, and Dave happens to be sitting in the Boulder area. So Dave Petroy has been doing several of these workshops for us, and he has just a wealth of information to share with everybody. He's got an MS in geophysics and a BS in zoology, which is quite the combo. And then he started his own business now that is, I mean, after being the founder of Blue Valley Energy. So when I was living in Boulder, I remember that geothermal company. And so now he's the owner of NTS Energy, which is dealing with like heating and cooling solutions and solar solution consulting. So that's why he's done a lot of research on heat pumps, because that is the trend that we're seeing. So Dave, I'm gonna let you take it off from now.
Thank you, Mary. Okay, I'm not gonna review, we just went through the agenda. I'll say that I have 27 slides, and if I do well, we'll get it in about 30 minutes. So for those of you who aren't familiar, we'll start out with the basics, a quick review of what is a heat pump. And the thing is, heat pumps extract, concentrate, and move heat, and not temperature. So people get confused, like, how can the heat pump, when it's 0 out, heat my house to 70 degrees? Well, cold air actually contains plenty of heat. Minus 10 degrees Fahrenheit has lots of heat. If you go to absolute 0, minus 460, the heat pump wouldn't work. But there's plenty of heat out there, even in the winter. And an air conditioner is really just a one-way heat pump. So let's just look at this basic diagram for those of you who aren't familiar, and just go through quickly how it works. So you have something called a refrigerant. This is an outdoor unit. This is the unit that sits outside that looks just like the air conditioner. And inside there is a refrigerant in a very tight coil, and the refrigerant circles up through, and the fan blows, and it absorbs heat. Now, refrigerants are pretty special in that they love to absorb heat and change phases. If you put a refrigerant on a stove to boil, turn on, it would be very fast to boil. So that's how well they absorb heat. So it's going to warm up here in the fall and the spring when it's 40, 50 out. It's going to get some more, it'll absorb more heat versus the winter, but it's going to have heat, and it's going to go into this compressor. This is where we do have to add some energy. We compress it and warm it up to about 110 degrees, and it's a warm gas. And then it moves into your house, goes into an indoor unit, which is called an air handler. It looks same size and shape as a furnace, or it could be a furnace with a coil on top like an air conditioner. Comes in there, the fan blows the air by this coil. It's a warm coil. Oh, geez, too soon. And basically the warm air goes out into your house, into your duct system in this case, and heat your house. Now, one thing to note, the air coming into the ducts from a heat pump is around mid-90s, between 95 and around 100 degrees. So if you put your hand in front of the duct for a heat pump, it's going to feel neutral. It's not going to feel hot like a gas furnace. That's okay. It's working fine. Remember, we're just going to get the house to 72. And so that's plenty warm, but it's just something to note. So we're going to talk about the arrival of what we call cold climate heat pumps. Heat pumps have been around a long time. Since the 1950s, they're put in homes. but I'm going to call them classic heat pumps. They just really weren't designed to work when it was cold out, below 32. So they're in the southern climates. Basically, come wintertime, they put the top on them if it's going to be below freezing, and they're not going to use them anymore. Around the early 2000s in the US, there was some heating oil price increases in New England and other factors. And so there started to be a lot of people work on the heat pumps and the research, and they realized, and they knew, there's no reason that heat pumps can't work below zero or in cold climates. And so there's a lot of R&D put into it. And actually also at the same time, or a little sooner, in Japan and in Europe. And so the idea was, let's design and build heat pumps that work in all climates. And so they did a few things. One was the ability to have heat pumps to defrost, so they didn't get all frozen up. Obviously, that has to happen. But then they looked at every component. So that's the nice thing about heat pumps. There's lots of things that engineers can keep working on and improving. The compressors, which I talked about in the previous slide, that's what adds the energy. They worked on making them a lot more energy efficient. Originally, compressor was on full blast and off. Now they're in continuously variable. So in the fall, if 55 out, you don't need much heat. That doesn't compress much. If it's the winter, it compresses more. That was one. All those alloys where I say that the refrigerant's on one side and the fan's blowing by and taking the heat out, the alloys are better conductors, the fan design's more efficient. And the other big thing was, the evolution of computer controls. So not only is it tell the compressor how much it needs to compress, but inside it was the outside unit, the inside unit talk to each other, and they only work as hard as they need to, and they're matched in how they work. That's actually about 15 to 20% improvement in energy efficiency. And so now, since about 2010, they really started booming. New England, Minnesota, they've been in Canada longer. There's tens of thousands of these units in the US, and they'll work well in all Colorado climates. And in fact, we have 4 heating zones, 4 climate zones in Colorado. And there's only one other state that has more, and that's actually California. Most states have 1 or 2. So we're a bit unusual, and we have the high elevations. And these heat pumps work fine. We're going to be talking about how they work in 6 and 7, but it applies to all these climate zones. So if you're on from another part of the state, it's easier for the heat pumps, and they're even more efficient. So for those of you who are sort of HVAC geeks and don't think about this all the time, some important terms I'll just be mentioning. Tons is heating and cooling tons, not weight. So it's 12,000 BTUs per hour. In most homes and apartments, 3 to 6 tons. And you'll see that on the next slide. SEER, I think most people know, that's just cooling. That's a rating of air conditioners. The higher the number, the better. 24 is half the energy of 12. Kind of the equivalent of SEER on the heating side with heat pumps is HSPF, heating season performance factor. The higher the number, the better. Right now they go between 8 and 13, and I'll show you that evolution. And the last thing is coefficient of performance, and that's a good way to compare different technologies, because that's saying how much energy in, how much energy out under a given set of conditions. And that's an easy way to compare furnace technologies to electric heating to heat pumps. So furnaces are 0.8, which is 80% efficient, to 95.95. Electric strip heat is 1. Air source heat pumps average about 3 over a season, and a 3 COP uses 1/3 the energy of a 1. So that's why, compared to electric heating, think of all the reduction in energy. So all those improvements in all those things inside, what do we get out of it? Why is that even important? Number 1 was efficiency. So over here, this is that HSPF, higher the number, the better. This is 8.2. So this is around 2012. And these are commercially available systems. So if you went to some of the manufacturers, that's what you'd be able to buy. Over time, every couple of years, they keep improving. And now today we're at, the best is around a SEER of 13. The majority of the manufacturers, they have several, 2 to 3 product lines each between like 9.5 and 11 in here. So if you look at this orange is the improvement in efficiency over time. And so right now, about a 33% improvement in efficiency. What does that translate to? Operating costs. So 1/3 less to heat with a heat pump in 2021 as opposed to back in 2012. So huge improvement. The second thing, aside from defrosting, that's important is they have to have enough heating capability to heat when it's really cold out. So this bottom axis here is outdoor temperature from 0 to 60. And this is that, remember I said tons or BTUs. So this is 0 to 65,000 BTUs of heating. 60,000 would be 5 tons, 12,000 times 5. The green line is a home that, and this would be how much heat it would required for that particular home to heat. As it gets colder, it needs more heat to keep it at 70. And now this is the evolution. So about 10 years ago, 12 years ago, before cold classic heat pumps, this is all the amount of heating they could produce. And notice below freezing, nobody really cared much. They could not heat this home, right? They had no chance of heating this home. But now over time, every couple of years, this line kept moving up, moving up. And now we have these cold climate heat pumps, which can maintain their amount of heating all the way down to below 10 degrees. It's only around 5, 10 degrees that they start to tail off a little bit. And they're able to heat all the way down to be between -10 and -15 degrees. So this is the big improvement. Now there's still a little wedge in this home, but that's easily taken care of. And you'll see in the next slide that this is very little. And inside that air handler is an auxiliary electric heat, which will supplement, or if you put a heat pump with a gas furnace, that's when the gas furnace will supplement in the coldest temperatures. I think this, a lot of people who aren't familiar with this so much get a little surprised by this. This is up in Eagle, and this is the outdoor temperature over the years, 60 to -20. And this is how much energy is used, the percent of the annual energy use. So notice 1/3 of the energy use for a home in Eagle is up there about above 30, above freezing. And then you have this big, huge bulk, most of it between 15 and 35, and then slightly less than 20% when it's really cold. And if you think about it, below 0, it's a very little part of the wedge. So classic heat pumps only did this, not very useful in our climate. Cold climates can do all of this all the way down into here, and they might need a little supplemental over in this section. So it's a very good system for our climates, even the coldest. So today we're going to talk about two strategies. So you have ducting, and you have pretty much whole house ducting. And let's say here you've got a furnace right now, and maybe you have an air conditioner up too. So we're going to talk about two different things. One is getting rid of the furnace and the air conditioner. And over here, it's a heat pump system. So you have a heat pump on the outside, and inside you have what's called an air handler. And inside the air handler is a little bit of heating. They call it a heating coil. It's in there, just that little bit of supplement, all electric. And in the other case, we're going to talk a little bit with natural gas. You can do a gas furnace. This is a heat pump. It does the majority of the heating, and you use a little bit of gas as the supplement, or maybe a little bit more, but that's called a hybrid or a dual fuel system. So most of the people on are, I'm sure, with natural gas. We do have a few propanes, but I'm going to start with the easy one first, and that's propane. So if you decide to replace your heat pump or propane furnace / air conditioner with a heat pump, what do you get out of this? Well, number one is we talked about the amount of energy savings. It uses 1/3 the energy. COP of a 95% propane furnace is 0.95, a heat pump's 3. So you're going to reduce your energy use and your heating bill, because propane is pretty much on par with electricity in terms of heating costs per unit. And you're going to reduce your bill by 40 to 60%. Well, why is there a range? Well, there's a range because each house is a little bit different with sizing in your duct system, et cetera. But you're going to have a big amount of saving no matter what. Well, you're going to get cleaner indoor air. you're going to reduce emissions from your home, and I'll show some graph on that, 50 to 75% by 2030 up in Holy Cross territory and even in Excel, most of Colorado. Provides heating in addition to cooling in addition to heat. So saves money, keeps you cool. And this is an interesting thing that I'll show at the end of the talk. It's a very interesting project by Northern Arizona where they're able to map emissions in cities over 24-hour periods. And you can see from different commercial, and the green is residential. So anyone at the end of the Q&A wants to hang around, I'll show that video. It's quite interesting. They've done Indianapolis, LA, Salt Lake, and I think Phoenix so far. So you're going to replace your propane furnace. Let's talk money a little bit. So I've done just a house, let's say about a 2,200 square foot house. For those of you who are keeping track of tons, about a 4.5 ton house in Eagle at design temps. I got a furnace. It's going to cost around $4,100 a year. I'm going to use 1,780 gallons of propane. I say I'm going to put in a heat pump and an air handler. In this case, I'm putting in a heat pump. I'm going to cut my heating in about half, save $2,000 a year, get rid of my propane needs for heating. So that's a big savings. What's it going to take up front? Well, if I just do a furnace, $12,500, and everyone on the call, I know there's probably, if you're in the business, you're going to say, hey, this could be off. We're just trying to give ballpark costs and relative costs. So these numbers are in the ballpark, but you can get wide ranges in bids. But we're like $12,500 to a furnace. You get no rebates. And in fact, if you want to do a furnace and an AC unit, it would be close to low 20,000 or 23,000. Well, let's go with a heat pump and an air handler, all electric. So you got close to about 25,000. But the utilities, one thing the utilities on Colorado really want us to move toward more energy efficient technologies. And Holy Cross is a very nice rebate program for the heat pumps. And also Walking Mountains and other organizations have some pretty nice rebates. Now there's a couple other costs. This is basically to take the stuff out, put the heat pump units in, but depending on your system, you might have to have an electrical panel upgrade, and you might have to do some stuff with your ducts. Those will add on, but still with these rebates, and in fact, if you do these kind of improvements, often some of these other organizations will help even offset a little bit more of that. But realistically, with your 2,000 savings a year, you're looking at 3 to 6 years, and then you're saving quite a bit. And also, you're now off of propane, which the price of propane, as people on it know, can go up and down quite a bit. So let's talk about gas. Most people on the call, I'm sure, are gas. The benefits are all the same except one. So I'm going to use less energy again. I'm going to have same situation with air. I'm going to reduce my emissions. I'm going to provide cooling. But gas is very inexpensive fuel. So while we've made these great leaps in heat pump technology, and the gap between gas heating and heat pump heating, the operational cost has closed quite a bit, that gap, it's still a bit less to heat with gas, and I'll show you in the next slide. However, so we're going to talk about a couple options and strategies. You can take the gas out if you want to move away from gas and go with the electric heat pump and the air handler, just like we talked about with propane. Or you can go with the heat pump as your primary and have gas as a supplement. Now, some of the advantage of that over just the regular gas furnace is it's really inexpensive insurance against unexpected gas prices. Have the last decade, we've had steadily declining, pretty stable natural gas prices. Some of the stuff going on this winter reminds me of 10 years ago. And we're talking about equipment that's over 10 or 15 year life. So chances are good that we're going to have some ups and downs again. And you are now in control of it. You can decide if gas is way high, you can use more heat pumps. So this heat pump really gives you a lot of flexibility in what you can do. And also, if you just want to decrease your gas footprint, you have the equipment to do that. So what does it look like? Well, a gas furnace is sort of the same house, low heating costs, $12.82. I can do my hybrid system, and I can do 50-50 gas. I can set it so half the year is going to heat pumps down to about 30 degrees outdoor, and furnace so about 50, and I'm going to have just a little bit more, you know, it's slightly less than $300 a year. So, you know, not so much per month. And then the other option is I can put this in and go really have the heat pump do the bulk of the heating, like I showed before. It's a little bit more. And then I can go all electric. Well, let's see, we're looking at installing cost. I got my furnace, AC would be up here a little bit more, very close to the heat pump. Now, if I go 50-50, which means, you know, this difference is a little less, but the rebates really aren't there for that, because these rebates are really focused toward, you know, using the heat pump as your primary source. I've still got my panel upgrades. If I go with the heat pump, the 80-20 rule, I've got all my rebates involved. And if I go all air, I've got all my rebates also. So, like I said, all the other benefits, and I'm going to show you next one of the big benefits for those who are thinking, you know, emissions and the climate, et cetera, when comparing. And this is going to show this big benefit over time. So on this left side here, this is the pounds of CO2 emissions over a year up here. And I've got these 5 bars or 6 bars, and this is 2020. So this is when a lot of the utilities in Colorado, Holy Cross, we're around 44% renewable energy. And this is how much each of these different technologies would emit. So this is a heat pump, full electric right here. We're only gonna look at 3. And then this is gas propane furnace, these 2 bars here. And this would be sort of if you had a hybrid, but not many people have it right now. So if I go cold climate heat pump, what happens over the next getting near 2030? Well, as we move to 2030, all the utilities in Colorado are rapidly moving towards 75 to 80% renewable energy, decrease in emissions. Holy Cross is the one leading the way. So up here, it's going to be even faster. But getting to 75%, very, very achievable. It will happen. So all of a sudden, if I go all electric, my heat pump, my CO2 drops way down, my emissions from my home. If I stick with gas, very little change. The only change is due to the little bit of electric that you run the fan. If I go with the heat pump and the hybrid, it also drops down some. Now, to put this in perspective, I can go out and buy an electric car. I can spend $35,000 up plus. And what's that going to do? That's going to typically cut about 15,000 pounds of emissions out. So to put this in perspective, we're looking at big drops in the order of going out and buying an electric vehicle for your heating and cool, but instead just doing this with your heating and cooling system. So I want to switch gears for 2 slides away from ducted systems, and you'll see on the next slide why I want to mention this. It's multi-zone mini split heat pumps. That's a little different strategy. It's where you have a heat pump unit outside, and rather than ducts, you have 2 refrigerant lines and a power line that go in to these various units in the house. For residential, you can typically have up to 4, and they might be on a wall. There's ceiling units, there's floor units, there's different things you can do. The beauty of this is these are only 6-inch. They only need about 6-inch lines, and you can get them into most places in your house. So and each room is controlled individually. Now, why would I have this in the ducted type? Because some of you might be doing additions and remodels at some point. So what's the advantage of this? If you look at an addition, a remodel, you might, if you're going to extend your big system like HVAC, you might have to upsize the whole thing. You might actually have, if it's, well, this says radiant in prior talk, but ducts, you might have to extend your ducts. You might have to rework your whole main system. Well, rather than do that, you actually can have lower cost by actually putting in a mini split heat pump to work on these specific areas you're at. It's very straightforward installation, very simple, and you're going to have great climate control in that area, and you're not going to potentially compromise your main system if it's not done very well. So this is a good strategy. I just wanted everyone on the call to be aware of that. So how do you make sure you get a good heat pump system? Well, we're going to talk about a few things: contractor, design, specs, and installation checks. And the idea isn't for you to become experts like contractors, but it's just to basically to know enough to make sure that you're going to get a good system. So selecting a contractor. Well, there's a lot of local resources, Mary's group, Nikki's group. There's several groups up in the high country that have really focused on this. And they have lists and they can recommend. There's more and more people putting them in up there. You can get some friend recommendations. When you get those, I recommend that you go to the websites. You can also go to the manufacturer's websites, search around and see who like the gold star installers are. Then go to the websites and people are recommending, you're like, yeah, that's good. I'm going to go investigate. Do they talk about heat pumps on their website? Now, I'm not going to, these folks are really busy. Do they spend tons of hours keeping up with the top-notch websites? Maybe not, but they should at least be mentioning that's part of their business. And you can call them and talk whether they've installed a lot. Are they trained in heat pumps? Get a feel. Are they excited about heat pumps? Are they looking at it as a really key part of their business? And I recommend, everyone's busy, but I know in the past there's been like, well, get 5 quotes and take the low, or 3 or something. I recommend going out and getting a couple quotes to start. These, if a contractor is going to do this well and do it right, it takes more than in the past where it was just kind of, here's the size, I'm going to do a swap out. If they're way apart, then it's tricky. Then I'd, go get another one. I'd be cautious of low quotes, and I wouldn't. If you go online now, you can go online and think that you can get this stuff for super low cost. Well, this is different, and this is an investment. It's 15 to 25-year investment, and you want to be able to get boards and parts, and you want people to be able to come out and check the refrigerant and do the stuff just like an air conditioner that's necessary to make it work well. And you're going to have a lot of support on local side. Online, I've looked at some of these places that are dishing it out, and there's really not a lot behind it. It's basically a warehouse that's pulling stuff, importing stuff, and then selling it online. So just a word of caution. So I want to talk a little bit about avoidable design installation issues, and then we'll go through in a little more detail, because they create sometimes heat pump mistakes. Still, I don't think this is happening very much anymore, because I think most of the technologies are cold climate, but there are cases where someone's putting in a heat pump. They think it's a really cold climate, but it's not really designed to do well in cold climates. They don't get them sized right. The temperatures used for the wrong climate zone, they're undersized, and a couple other things. Now, your home has existing ducts. They could be fantastic, or they could be medium, or they could be not very good. If you put a heat pump in, it's not very good. I mean, into a duct system, it's not very good. You might think, well, the heat pump uses more energy than I thought. Well, it might be because of this. And in some cases, they're just set up a little bit wrong. The specific example, someone goes and installs a heat pump in, they do the settings, and they're supposed to be that the heat pump heats down to like 10 degrees outdoor and then uses a little bit electrical. But someone it was late on a Friday, and they set it to 30 degrees, and all of a sudden the customer is like, wow, my electric bill's high. Easily fix it. So what are the misconceptions? A couple of them. Oh, the heat pumps don't work when it's very cold. They're undersized, they're under designed, or they were costing more than expected because they were put in a situation that they were not working ideally. So we're going to talk about first design. And remember, we're trying to get the bulk of this heating season with our heat pumps. So someone's going to run it called a manual J, and they're going to build a model in the computer. They'll look at your windows and put it in. And then they're going to say, well, all right, here's this example before. So here's the outdoor temperature. Here's the heating. It won't look like this graph. It'll look something different, but just to illustrate. So here's my house. This is what I need to heat. And here's heat pump option 2, the old style. And of course, it wouldn't do it. You know, it's way down here, and I'm way short. And I have to use all this electrical. I have to use all of this or more gas than I wanted to. But then here's the cold climate heat pumps. They come across. I still have this little wedge. Still have this little wedge in here. I need not much though. If I go backwards, remember that wedge is maybe that little bit there, not much at all. But this is a nice size match, this heat pump going along there. Now remember, you're up at high elevation, so you need to derate the equipment for the high country. In other words, thin air doesn't hold as much heat per unit of air, so you need to have bigger systems to get enough heat. So everyone operating up here knows that. So when they come in and they present their proposal to you, what are they, what's the annual heating cost estimates? Usually they'll ask you what prices to use. If they didn't, you can ask what they use. If it's all electric with the aux heater inside, you can ask, well, what outdoor temperature does it switch over? In other words, did they design it that it's going to switch here, or is it going to switch back here? So that's, a question. You just learn some more. Should really be 20 degrees or lower. If it's higher up, that means you're going to use a lot more aux heating, and you really want it to be less than 30%. Actually, that might be 10%, but there might be cases where you have a very big house and the biggest heat pump can only do up to 70%. And they're going to look at your ducts. We'll talk about this in the next slide. What am I gaining from the recommended duct system improvements? And they're going to talk to you. The heat pump's going to work better, more comfort. This area won't be cold. You won't use the electric as much. So how do you know you're getting a good cold climate heat pump? Well, talk to the contractor. They know their equipment well. They'll describe it. Just some tips. Does the manufacturer, when he hands it, they promote it as a cold climate heat pump? Some of them, Mitsubishi, Daikin, and that, it's all over their literature. Other ones, maybe not so much, but it is. HSPF, that factor greater than or equal to 10, and variable speed capacity. So in the high country, you need sort of the higher level systems because you want them to have high capacity efficiency when it's really cold. For those of you, there might be a few people on or watching the recording that are in other parts of Colorado, milder. You have a little more forgiveness. You might not need to be HSPF 10. The main thing, you and your contractor check that it meets the utility requirement rebates. They are different for the different utilities. And make sure they're part of a match system. And here's just an example. You're going to go on a website, and here they say, oh, it's a variable speed heat pump. It's a 10. Here's one here that's a 9.6 and it's a 2-stage. So that would be here. Here's one that's a 1-stage 8.2. This isn't good enough. So these are a few terms that you'll see obvious, and you can use them to get a sense of what your equipment's about. Part 2, ask them how noisy are the units. You can ask for the dB. There's a lot of improvement in these, especially the outdoor units, making them quieter. Indoor units should be, when they say matched, if it's sort of a high-end outdoor unit, you're going to want a high-end air handler, medium. So they'll match that. Most manufacturers and the installers, they want to do that. It makes their life easy. Ask what the warranty is, particularly the compressor warranty. That's sort of the heart of the system. So you want to know if it has an early heart attack, you just get it replaced. So ducts are the biggest challenge in retrofitting, but it's not that bad. I mean, you just have to really check through it. And so what your contractor, they're going to check the ducts. So in the unconditioned, partially conditioned spaces. Now, so you're going to go up in the attic, crawl space, basement, because you don't want to, they have to be good in those spaces. Unconditioned, remember I said it leaves the heat pump unit at about 110 and goes out at 95. So if you're uninsulated and leaky, that's not going to be helpful. So you're going to the extent they can do that visually, or they might have a sense from looking at the ducting by the furnace, how good it is. They can check the duct joint sealing. Maybe they'll pull it away, look at some quality. If they can't, and they suspect something, you can also pay for a duct leakage test. There's ways to do called duct blasters. And you want to ensure they're well insulated. The reason I talk about the basement is, the basements a lot of times are conditioned, but you have a lot of surface area in there. And you could have an extra warm basement in the winter or an extra cool basement in the summer, which isn't as good as having the heat up in the house. They're going to look at the ducts. They're going to go around and they're going to count all the supplies and returns. Heat pumps generally need a little bit bigger airflow than furnaces. So if you want to get really the top efficiency, they're going to count that, and then they're going to see what they can do. Now, it doesn't mean that you absolutely have to do it. What it means is you can still do the heat pump. It just might be not quite as high efficiency as if the duct system were perfectly matched. They might go around and say, I want to add some supplies here. I want to add returns, which if it's an unfinished basement is easy to do, or up in an attic. Returns are pretty easy because often you can locate one near the central furnace and just go up there. And it, even if you have a finished area, it's pretty easy to do. In rare cases, they might add running a small trunk line. One other thing that's a really good strategy, you can zone the duct system into 2 zones. So that means in here, if I see the big trunks going off, I don't have to cut up into my house or anything. I can just put damper controls. Well, that gives you a couple of advantages. One is you're going to have 2 thermostats or 3 thermostats upstairs now, and it's breaking into smaller systems. So these units now can ramp up and down, as I said. So smaller systems, they can ramp down and do smaller areas, so it can make it work better. People will talk about electrical. So if you have a 100 amp electrical panel, chances are you're going to need to upgrade the panel to 200 amps to accommodate the heat pump. The situation where you won't need to do that is if you have a furnace and an AC and you're running on 100 amps and you put in a heat pump with a main unit where the gas is supplemental, then you might not have to upgrade. It depends on the size. That's the only case. But generally, we're probably going to have to do some upgrading unless you already have a 200 amp panel. With the all electric heat pump, remember I talked about that little supplemental inside the unit. So you don't have to know all this, but they're going to talk to you about an auxiliary heater. And just to give you an idea, so they're going to say 5, 7.5, and 10. And that's just how much extra heat do I need when it's really cold, way below 0, and the heat pump might be a little short. So this is just sizes. The 10 kW is normally a couple stages. I would ask them about that. It's kind of easy to necessarily make these bigger out of safety. It really it'll add cost and just in terms of the size of the circuit breaker in the line, probably not much, but just so you're aware of this when they're talking to you about it. 10 kW just for operationally normally is 2 5 kW stages. So it rarely ever runs at 10 kW, quite frankly. So you're going to need to know about that. Outdoor installation. So these are going to run all year round. And they're quieter, but they're not, not zero noise. So be aware if you hang out of the patio a lot, you might want to not have it right next to the patio. If you keep bedroom windows open, you want to keep away from that. If you mount on the wall, good installers like this one here, vibration mounts are great. Where you put it out there, the sun helps it defrost. You can avoid the north or the west wind. not essential, but little tips if you can. The southeast corner is really nice in Colorado. You got to do this. I don't want to be shoveling out my heat pump, and you don't want to be calling the contractor to do that. Nice shelter over the top. These are up way high. Remember the snow depth. If you read online, some people say, oh, it's 12 inches. These are the standard heights. Well, that's not going to cut it up in the high country. Now, rifle, probably fine. And you want to have this be, well done. Here's the bottom line. Ask them for a few pictures of installations. You'll get a good sense. So summarize, they work great in Colorado, cold climates. There's a lot of advantages. We talked about many of them. Just get a feel for the basic ideas on design installation so you can ask the right questions. And you're talking to a couple, you'll get a sense of their answers and who's really, hopefully both of them really know their stuff. Work with them as a teammate, because you really want to get the best thing in. And, I'm giving you an overview of a lot of the stuff, but you got to trust them. I might say, okay, location southeast is great, but in this case, we're going to do it on the west because my line set is much shorter, and that makes sense. And talk with the local contacts, Mary, Nikki, all of them. I mean, they can really help you out. So that's it. Thank you for your time.
Thanks, Dave. Do you have the other rebate sheet that I sent you, Dave, before this one, or no?
This one?
Yeah.
I got them backwards, sorry.
So I apologize to everybody and our sponsors specifically, because when I introduced the webinar earlier, I did not mention our sponsors. So I'm so sorry. Our main sponsors are listed on this page, as you can see: Walking Mountain Sustainability, CORE, which is the Community Office for Resource Efficiency, Garfield Clean Energy, and Holy Cross Energy. We also have sponsors of the Beneficial Electrification League of Colorado, Colorado Energy Office, Energy Smart Colorado, and who else did I miss? I think I got it all. Our Climate Action Collaborative here locally is also a sponsor. So on this page, just for your reference, when you get these slides later, you'll be able to reference and see kind of what kind of heat pump rebates you can get in these local areas, whether you're in the area of Walking Mountains Core or Garfield Clean Energy. We all offer heat pump rebates above and beyond and on top of what Holy Cross Energy offers. So now I'm going to hand it back over to Mary for that other page you had up, Dave, and let Mary talk to you about the Holy Cross Energy incentives.
Okay, I'm going to get back to that page.
Together. Yeah. Thanks, Nikki. Thanks, Dave. That was really informative. A lot of us don't look at our ductwork as part of the problem, and it's such an easy solution to seal your ductwork and everything.
Wow, this thing's active.
Did it disappear?
No, there. No.
Use the back, or yeah.
I know, my arrow keys aren't working.
Okay. Thank you. So a lot of, so Holy Cross has energy efficiency rebates, and then we have electrification rebates. And how we're defining electrification is that you're going to fuel switch from natural gas or propane and go primarily with heating with electricity. It's a bonus that these heat pumps do cooling, so you get two for the price of one. So have gas or propane already, and you're willing to use that heat pump 80% of the time primarily, you will get $850 per ton. So Dave explained that 12,000 British thermal units equal 1 ton. So your contractor usually will give you the size in BTU, and I can help you with the math. So that's it. We want to make sure that you guys, I cannot stress enough that you talk to your contractor and say, I want to use this for heat in the dead of winter. Because a lot of people are calling them right now for cooling specifically. And so they'll give you what we call a standard heat pump. And that's not, they might go down to 14 degrees or 5, but these cold climate ones really go below 0. So you really got to specify, I want this cold climate. And that's where the heating seasonal performance factor needs to be 10 or greater. You can send me or Nikki the model number, and we can tell by the model number if it's actually going to be a cold climate or not. If you are electric already, so electric boiler, furnace, or electric baseboard is what we have a lot of. That's actually energy efficiency because you're going to actually really save on your bill. So we're going to give you 600 per ton. And then if you're only going to use it for cooling, because these heat pumps do a great, they're one of the most efficient way of cooling, we'll give you 100 per ton. There are some questions about heating or water heating, which is your second largest utility bill. And so there are actually heat pump water heaters. They actually are kind of a standalone, so they don't work with a boiler system. Like a lot of us have boilers in this area, but there's actually a heat pump water heater. They are hopefully coming out later this year with some that will work on 120 volts. So you don't necessarily, if you already have gas or propane water heater, will need to get the electrical upgrade. So I'm really anxious to that. But if you are going from a gas or propane water heater, we will give you 1,450, which is a really good deal because that about pays for it. And then again, if you are electric water heater, this can save you up to 60 to 70% on your water heating bills. And so we'll give you a $450 rebate. And then a lot of us love cooking with gas, and someday we are, when we can meet in person, going to do a demo, right? I just bought a little 1-burner induction and experimenting with it because I have a gas stove at home. So induction cooked up, especially if you're remodeling your kitchen, really consider that. There's a great demo on Core's website with a chef cooking on induction. You don't, everybody's like, oh, I need special pans. And really, if a magnet sticks to the bottom of that pan, it will work on induction. It works on that. So we think that electrification is really a great way to improve the health and quality of your life in your home, since we're spending so much time inside our homes now.
Thanks,
All right.
Mary. That was all
Yeah.
great. You both gave such great information today to us. I'm going to ask the first question, Dave. What would be a bigger upgrade as far as energy efficiency and eliminating natural gas? Would it be replacing the furnace with a heat pump, water heater from natural gas to hybrid, or natural gas stove to an infrared one?
It's clearly upgrading the furnace to the heat pump, because that's the bulk of your energy use in your home. And like natural gas, the stove is only 2%. The heating can be as much as 40%, and the water heater is around 15% roughly. So definitely the furnace.
But I would add, if you really do want to eliminate natural gas, you should do all of those things.
Yeah. And there are some people that do want to do that.
Yeah. But the order is heat pump, furnace, water heater, stuff. That would be the order.
We do have one question here. Is it possible, Dave, to tie a heat pump into our water heater? If so, what's the cost comparison between using a water heater for just AC heat in the home and tying it into the water system?
There's not, in Colorado, there's not really heat pumps for air to water readily available. It would be much simpler and a cleaner thing to do is just go and get a heat pump water heater. That would be, and just replace it and just go straight heat pump water heater, then tie them together. The cost and then the complexity would that's just the way to go there, definitely.
Yeah. And we do have a question on Colorado Springs. So Dave, do you have any local contact recommendations in Colorado Springs? I don't think Nikki, that's not her territory.
Let's see. Also, I know the person in Colorado Springs had some other questions, which I have to pull up my cheat sheet after we go through these.
I just asked them to email me individually. I can get them connected with folks.
Yeah, we can get you some contact. Email us and we can do that.
So if you're outside of out of our lovely Roaring Fork Valley or Eagle Valley, then just email and our contact information will be on the slides, Nikki or myself, and we'll help you get there. So here's a good one because I'm an electric company. Can solar panel electrical input be used to supply the heat pump?
Certainly, absolutely.
Yes.
So,
that's a great combo, actually. So if you are thinking of eliminating gas or propane in your house and going all electric, depending if you have good orientation on your roof, that's a great way of reducing your costs. And Holy Cross does have renewable energy rebates, solar panel rebates. So, and we have a list of preferred solar installers. So same thing as we always recommend, get a couple of quotes and we'll help you with that too. So that's a great combo, going all electric with solar on your roof. That's about as green as you can be.
And Jim just asked a question, if we provide incentives to move from a gas cooktop range to just a simple electric one that's not induction. And I guess, Jim, what I would tell you is we are working on rebates for next year, and we've definitely had that comment in the past. So it's something that we're going to look at and consider and think about for this year. And for right now, I think we're all just rebating induction stoves.
I concur with Jim, by the way. I've written some stuff on that. I think that
definitely
would be something
that we
very,
yeah, that's a good feedback
strategy, actually.
Right. Because we know the induction, I think what they're putting in some of the pilot mobile homes, they're about $1,700 to $2,000 for a whole induction range.
But
that's great feedback.
Anybody else have any questions? If we missed anything, please just raise your hand or type it in the Q&A box, and we will get Dave to answer it while we're still on the phone for a few minutes.
I can go to my cheat sheet.
Dave's going to go ahead and answer questions from what you asked.
I have my cheat
registration.
Don't be everyone's looking at. All right, here we go.
Quick, Dave, quick.
Can everybody see this? I don't want you to, but that's okay.
No, we cannot see it. All we can see is your slides.
All right. Okay. So what's the difference between high efficiency and standard furnace? Is high efficiency furnace have a secondary heat exchanger. So standard furnace, once it burned, the heat went out the top. It goes into a heat exchanger, so you get extra heat out of that. Someone asked, they said they have 3 thermostat controlled gas heaters in my house in addition to central forced air. Do I need to replace those also? Because I just use them for room to room. And if you want to go all electric, sure. If you don't necessarily need to go all electric, you can leave those little gas ones in for the few times you use them. If you want to go all electric, you could put electric baseboard in, or you could go with a mini split too. It depends on, what your goal, how much money. Is there a limit to the size of the home? This will work for vaulted ceilings. If you're in the high country, so the largest single residential unit is 5 tons or 60,000 BTU. And depending on where you are and the quality of your house, so like in the high country, that might do, say, 2,500 square foot house, just rough. Some better new houses might be more, older houses might be less. On the plains, you might get a little bit more. So really it has to do with how much heat your house needs. But that'll sort of give you some guidance. And I wouldn't shy away from it, because even if you have a bigger house and you have one furnace with a duct system, if you can't get a big enough heat pump with electrical, you could do that hybrid. So is this
Dave, can I answer? Yeah, Dave, there was a question, Nikki answered it, but I think that was a good one about understanding net metering in our territory. So someone asked that she thought all of her electricity that she was generating with her solar panels was going to the grid. That's not the way net metering usually works with our residential. So just know that if you have solar panels already on your roof, your solar panels are generating electricity and your home is using electricity at the same time. So if your home is consuming more than the panels are generating, your meter's going forward. So you're getting some benefit from your panels, and then you're getting some electrons from the grid. But if your home is super energy efficient and you're just not at home, and the panels are really generating a lot of energy and you're not using much electricity right then in the home, your meter will go backwards. And that's when you start feeding the grid. And then every month you'll see whether you banked kilowatt hours or not. And then when you bank kilowatt hours, you use them the next month if you start using more electricity as we go into the winter months. So, and then Holy Cross will kind of true up with you, we call it, at the end of March. So April 1, everybody that has any bank kilowatt hours are going to get paid for those. And then you go 0. And so your production. So just know that with net metering, if you have panels in your roof, the electrons are going into your house and you're using those that solar generation as you are using the electricity in your home.
All
All
right.
right,
Mary.
sorry.
Couple more questions. I'll do it quick, and then we can watch the video if people want to hang around.
You really want to see that video.
It's pretty cool.
All right.
Is this a positive movement toward improving the climate of the earth, and how? Yes, because they use 1/3 the energy is conventional, and as the grid goes greener, more rebates and more renewable, definitely. What's recommended backup system in case of power outages? You have two choices. That's assuming you're not on gas, but you could get a propane generator. You can go whole house batteries. There's a big cost gap, but you can look at those two technologies.
Yeah. So can I
space-
just, sorry, Dave, can I just say that Holy Cross does have a Power Plus program, which is the resilience, and it's the Tesla Powerwall batteries. So we do have battery options for you as when the electricity goes out. And don't forget, if the electricity goes out, your furnace isn't going to work, or your boiler, because they all have electric starters.
But you could put a little battery for that. But okay, can space heating pumps can heat pumps be inside the thermal envelope? No. We live in Colorado Springs, interested in all listed topics. Okay, those are people who ask about service providers in the area. There's another question. Can they work with hot water radiant heating systems? That was the last. I would recommend asking Nikki for the last seminar, because right now air to water heat pumps directly for the radiant is not really available in Colorado, but there's a fantastic solution. Mini split heat pumps in the home, complementing with the radiant is a great, and so last week's seminar was about that. And the final one, how much it costs to heat pump on a 2,300 square foot home. We need more information, so if you want to email me, my email's on there, or Nikki or Mary, and they can forward it. Just would need some more information to give you some idea.
Yeah. So I think everybody understands in our territory, Dave, that the labor costs are high. And so the equipment itself is not expensive. It's so with when you get closer to a 3,000 square foot home, I mean, you might be looking at $30,000, and there is some financing with the Colorado Renew, RENU program. So there is some financing. Very good. So, so just know that these heat pumps, I know they work for 20 years, so it's a good investment. So, so just know that we understand the rebates are helping to bridge that gap between putting in a gas to going to all electric, help bridge that incremental price difference, because I've seen quotes for gas and furnace and AC up to 20 grand right now too in our territory. So
can we do the video now?
You are so
this is a grand finale.
Dave would okay, wait, yeah. So I think if anybody has any more questions on heat pumps, let's just go there first, Dave.
Okay, yeah, sure.
So any more questions? I think, Nikki, we got all of them. I don't see anything new. I think
we got all the questions, but yeah, make sure you email Dave or Mary or myself if you have any more questions, or if you need connections, or if you need materials or educational information, anything that we can help with, I think. And I'm going to go ahead
review quotes. Yeah, I would say big time. Let us review quotes before you sign with the contractor, just so we make sure it looks like we can rebate that unit. So that's what I would say. Call us before you spend.
I'm going to go ahead and stop the recording now. Oh, here's one more.
Oh.
If we're in an older house, would it be better to replace windows and winterize, or move to a heat pump?
Energy efficiency first, always. Yes.
That's a tough one. I mean, it depends how old your windows are and how many you have.
Yeah.
I would say,
Nikki can weigh in.
Is more important. But
I would say sometimes you don't have to replace all your windows. Sometimes you can fix a lot of problems with sealing around your windows, maybe, and fixing windows that need fixed, and then doing just some general weatherization that doesn't tend to be super expensive. And doing that first would really help you size your heat pump right and spend the proper amount of money instead of too much or sizing that too big,
Installation
losing it
is
all.
really good. Windows, I mean, okay, the standard answer is sure, replace all the windows, but it really depends on how many windows and, you know, if they're
Well, how
single
leaky
pane
they are
double
too.
versus
Yeah.
kind of intermediate, and windows can be expensive, so.
Yes,
Lots of
they are.
variables.
Yeah. Yes. Well, Jim just said depends on window age and also can replace only windows where they are typically
You know,
live,
I
like
would
the
have
family room.
I would have an energy. So my recommendation would be hire someone who do an energy audit. It wouldn't be that much relative to what kind of money you're thinking of spending. And they'll give you a much better idea of,
Right.
of what would make the most sense.
Right. So Nikki,
a-
do you want to tell people about the energy audits you
That's an
guys do?
excellent answer, Dave. Thank you. Walking Mountains, as well as your partners through Clear and Core, also offer home energy assessments. So get a home energy assessment. And the reason I guess I said before, sometimes it's great to just look at fixing windows and maybe just replacing what needs to be replaced or sealing around your windows, is because that's what we find a lot in home energy assessments, that it's a big ticket item to buy new windows, and it might be just as effective for you to do some weatherization and sealing of those windows. So get an
So
energy
they-
assessment, find out really about your
Right.
house. There's way too many variables for us to really tell you on this webinar
can-
which is the right direction to go.
They can contact you, Nikki.
Of course, they can contact me and I'll get
That
them
was my
connected.
meeting. I had to set you up on that. So.
Yeah. Well, and Core does it. So if you're living in the Roaring Fork Valley in the Eagle County and Picken County, it's the Community Office of Resource Efficiency. So these are really comprehensive blower door, like a fan, depressurizes the house. They go around with the infrared camera so you can really feel the leaks and everything. So if you haven't done one of those, then actually it's a requirement for Core's rebate. Is it a requirement for your rebate, Nikki?
Yep.
Yep. So start with that energy audit and we can help you read those reports too.
Okay, I'm
All
going to
right,
say
let's
thanks
move the
everybody
time.
for coming today, and I'm going to stop our recording. Thanks for
And
coming.
get your popcorn out. All right.